Alright, so here we are. We're going to talk about all kinds of nice little functions here, linear ones, lines. These things you know, right? Have seen these before, have worked with these. Now again, a linear function, when we want it in function form, it's always going to be in slope-intercept. Y is equal to mx plus b. Just remember your slope is y2 minus y1 over x2 minus x. Constant function. If you are given just a number, y is equal to, just going to be a line straight across. You will not be given a function that is x equal to, simply because x is our input values, our domain. And you can get a whole boatload of different things out for y if you put in x equal to something. It doesn't matter. It's not going to be a function. Quadratics. These are fun. Some highlights that you definitely want to make sure that you take on this. This axis of symmetry, this idea that x is equal to negative b over 2a. Very important for this. It leads us to a couple of things. First offhand, identifies the axis of symmetry, and it also identifies the x-coordinate for the vertex. So if I know where the negative b over 2a is, I can put it back into the function, and it will come back and give me the vertex. Important things to have access to. Piecewise defined functions. These are going to be functions where it's only good for certain portions of it. And now I've got that on the for the graphing calculator on the whiteboard there on the bottom. Down there it says to graph piecewise linear functions. I've got information about how to do that. We played with that a little bit before, but now we can reiterate that. Special piecewise functions, absolute value function, greatest integer function, sometimes called step functions. Power functions. If it's even, it looks like this. If it's odd, it looks like that. Now, it's very similar to what you see on quadratic, right? Kind of the same whole idea. Well, that's because it's part of the power function, a specific power function. This n here can be any even number that you want. It could be 2, it could be 4, it could be 1,000, it could be a bazillion. But it can't be a bazillion and 1, because if it's a bazillion and 1, that's an odd number, and that ends up putting you over here. So it looks like this. Special power function. Things that look like this. Root function, if they are even. A root function, if they are odd. Looks like this. Now, all of these things, we call these ideas here in these pictures that we've got parent functions. When we see a graph that looks like this, we know that it has to have a certain form. When we see a graph that looks like this, we know that it has to have that equation in it. Likewise here. And here, absolute value function, 2 lines. It has to look like that. Step function has to look like this. So by identifying what these are, it kind of leads us down a path as to which one we are going to use to solve. Root function looks like that. Reciprocal function looks like that. So, when I'm looking at these, f of x is equal to x, find the domain and range and graph the function. Well, what's that going to look like? It's not a function, is it? F of x is equal to x. But put it in terms of that idea that f of x is the same as y. Now y is equal to x. Can you have a picture in your mind what this graph might look like? If you put in 1, you get out 1. If you put in 2, you get out 2. If you put in 3, you get out 3. So you get 1, 1, 2, 2, 3, 3, 4. Looks like you're cutting on a diagonal. So you've got a diagonal line here. What's the square root going to look like? Well, first offhand, can I put any negative values in for x? So we take the square root of a negative number and get another real number. The answer is no. That gets us to imaginary. Someplace else. Root functions look like this, so I know that the graph is going to start like this and it's going to go on. I have an idea of what it's going to do. What about f of x is equal to 3? Well, is f of x always going to be equal to 3? Is there any way that I can pick an x that is going to affect the value of this? The answer is no. This is just going to be 3. It's a constant. It doesn't have x added to it, multiplied by a power of, divided by square root. X is not doing anything to that 3. Constant. Always stays that way. So, what about these? What are these always going to be? Identify the type of each and then find the domain and the range. Graph the function. So, I am looking at x to the 3rd power. What is it going to look like? One of the things I always tell students to do, there's 3 things that you have to concern yourself. Positives, negatives, and 0. If I put a negative number in there, what am I going to get? Positive. Negative. I put 0 in there, I get 0. I put a positive in there, I get a positive. So that means it's going to be looking like things that are negative are in the 3rd quadrant. 0 is 0. Things that are positive are in the 1st quadrant. So, I've got a ballpark idea of what that could look like. Right here. Okay. Ax to the n. N was 3, correct? It's an odd function. Now, I'm not being very specific about a lot of this, am I? What does it look like? What is it going to do? How is it going to behave? So, getting back to this here, what about the 3rd root of x? Can I put negatives in there? Yep. Can I put positives in there? Yep. Can I put 0 in there? Yep. I can put anything in there I want, right? So I know that if I put a negative in, I'm going to get a negative answer out. So I know it's going to be coming from the 3rd quadrant. If I put a positive in, it's going to give a positive answer. It's going to be in the 1st quadrant. So I know that it's got to have some shape like this. So if I look at this, so that doesn't fit it, does it? Does this fit it? Well, if I take a look at what the formulas are, 3rd root, it's actually showing up here. This is an odd root of some number. It looks like this. You need to familiarize yourself with the picture in your mind of what these graphs can look like. Will help you quite a bit. What about this one down here? Can I put any number I want in there? The answer is no, I cannot. There is a number that if I plug it into this, does not work at all. How do I know this? 5 is divided by something. There is this little problem when we divide by what number? 0. Division by 0 is undefined. So I can put positive numbers into this thing. I just get fractions, right? And the bigger the number, the bigger the denominator, the smaller the fraction is. I can put a negative value in there. And will I get out negatives or positives? Positives. Because a negative number squared is always going to be positive. The only thing I can't put in there is 0. So I know that this has got to be in the 1st and the 2nd quadrant. I know that it is not going to touch the y-axis at any point in time because x can't be put in. So when I look at these functions, I get this. Okay? I know that it had to be coming from here and going to there, coming from here, going to there. Going and taking a look and knowing what the shape of these functions are. If it's a root, it doesn't grow as fast as if it's got a power to it. That grows fast. Things that are going to have a division by zero in it are going to end up having gaps in here. These things are going to happen. So, if I take a look at these type of things, now I got A here, okay? What blazes does that look like? The funny thing is, when we start taking a look at the leading terms, what the powers are, that's going to dictate quite a bit what this thing is going to be. So when I look at A, I say, hey, that's going to be it's quadratic. I got a second power on there. I know what it's going to look like. I know it's going to have this shape to it. There's no negative out in front of it, so it isn't flipped over. Looks like a chart. What does B have to be? It's got to be a line, right? 3x minus 18 fits that y is equal to mx plus b squared. What about C? Oh, I look at C here, 3x minus 4, is that linear? Is 8 minus 2x linear? Yeah, it's not right the way we like to see it, but it's linear. This only works if x is less than 2. This only works if x is greater than or equal to 2. Ah, two different things. I have a piecewise function here. I got 2 bits of the graph that I have. So this idea is, again, very general. What do you have to work with? What kind of an equation is it? What is the graph going to look like? Okay. Is A a function? Is B a function? Now, if you remember correctly from the vertical line test, if I draw a vertical line through it and it hits it in more than one spot, not a function. B is not a function. If I ask you to give me the value for, say, x equals 6, can you give me the correct value? No, because you'll give me a positive one, and I'll just be contrary and say, oh, I want the negative. Then you'll give me the negative and says, nope, I want the positive. A, if I ask you for what the value of 6 is, there's only one possible answer. Now, when you're going through this, make sure that you go back and you have this information. These pictures with the graph is very important for you to have. You've got to have this picture in your mind. You have to know what these things look like. Now, I realize that you think, I just printed off, copy and paste it, whatever. I actually recommend that in your notebook, for your notes, you actually go and draw out, give yourself a sketch of this, and put the equations in. Now, you might think that that's silly. It's a waste of time. Remember, you're in a college level class. And the information that you have, the better you can understand it, the better off you are. And honestly, to take a look at something, write it down, and have it for you in another form for you to use in a notebook, it's helpful. You got to remember, what goes into your brain and comes back out again does tend to stick in you. The more you do this, the more it's going to tend to stick in you. So, that is all I've got, and if you've got questions, by all means, ask.